So today we're going to be learning about composite functions. And basically, what a composite function is substituting one function into another. So, for example, we have f composed with g of x, which is really like saying f of g. F g of x. And then when working with composite functions, you always want to make sure that you're working from the inside out. So you start with x, you go to g, and then you go to f. Alright, now let's start with an example. Let's say that our f function, f of x, were equal to 4x. And let's say that our g function, g of x, was equal to 6x minus 2. And we wanted to find out the composite function of these two functions. So, like I said, we combine. We start with f composed with g of x, and we rewrite that as f of g of x. And we, like I said, we start inside and we work our way out. So we'll start with 6x minus 2. We factor that in. This is like saying f of 6x minus 2. Now, this is the first half. Now we have to factor in our f function, which is 4x. This is already representing our x, so we only need to factor in our 4. So we go 4, 6x minus 2. Now, all we have to do is distribute 4 throughout our brackets. So we go 4 times 6 and 4 times negative 2. And our answer comes out to be 24x minus 8. Okay. So, now with some simple math, we know that 24... Oh, sorry, no. So, this is our complete composite function. So, this is what f of g of x looks like. So, knowing that, sometimes you'll get stuff like this. F of g of it, but instead of it being x, it'll be a variable, or a number, sorry. It'll be something like 2. So if it were 2, and we've already done this, all we need to do is factor 2 into our x's. So, instead of it being 24x minus 8, it's now 24 multiplied by 2 minus 8. And then, so 24 times 2 is 48, and then minus 8. So we have 48 minus 8. Then becomes 40. So 40 is equal to f of g of 2. So there is another way to do this. There's another method. If you were to be given the variable 2, and this started at the very beginning, so still same thing. Let's just still say that f of x is equal to 4x, and g of x is equal to 6x minus 2. Perfect. All right. So, but this time, instead of it being x, the variable is now 2. So we'll go like this. F of g of 2 is really equal to f g 2. So we'll start by factoring 2 right off the bat into our g function. So we'll go 6 times 2 minus 2. So 6 times 2 is 12. 12 minus 2 is 10. So that is what our g function looks like after substituting 10. But now we have to substitute this value into f. So what is f? F is 4x. This represents our x, 10. So 4 multiplied by 10. 4 multiplied by 10 is 40. And if you look, what did we get on our last one? 40 for f of g of 2. So there are multiple ways of doing this. You could go the original way, find your composite function, your full composite function first, and then substitute the value in, or you can start substituting the value in right away and find your value through substituting the value into both functions instead of the combined function. All right, let's do a couple more examples. For our next question, let's say f of x is equal to x squared. And let's say g of x is equal to 2x minus 4. All right. So, like last time, we'll start out by writing f composed with g of x is really equal to f of g of x all right, and then from there, like we said, we start from the inside. So we go back, we know that g of x is equal to 2x minus 4. So we'll do f of 2x minus 4. And we see that f is x squared. So because there's no actual number, it's just x squared, and this is our x, all we need to do for f is square this. So we have 2x minus 4 squared. And that would technically be our constant function, but we would want to factor the square. So we'll do that as well. So we'll do 2x minus 4, 2x minus 4. And this is just simple. So we do 2 times 2 is 4x squared. 2 times 4 is, 2 times negative 4, is negative 8x. 2 times, 4 times negative 4 times 2 again from here is, negative 8x. And negative 4 times negative 4 is positive 16. After we add together like terms, we get 4x squared minus 16x plus 16. And this, all right, so for our last equation, I'd like to do not only just the f of g, but also the g of f, as well as show you how to find the domain of a composition function. All right, so let's say for this equation that f of x is equal to the square root of x plus 3. And let's say that g of x is equal to 2x minus 1. All right, so let's start with f of g. Let's start with f of g of x. Okay, let's start by factoring in, or substituting in, our 2x minus 1. So we have f of 2x minus 1. Now, we also need to factor in our square root. This time, our x is in front. We have square root of x plus 3. So, if this is our equation, if this is what represents our x, then we need to factor this into that. So really, this comes out to be square root 2x minus 1 plus 3. Now, what we can do from here is combine like terms. We see that we still have a minus 1 and a plus 3, so we can combine those together to get a final answer of 2x minus 1 plus, 2x plus 2 to combine like terms. And that would be our final answer for f of g. This would be our composite function. Now, I'd like to show you how to find the domain. When finding the domain, it's easy to set it up like this. If we go 2x plus 2 is greater than or equal to 0. Picture this like an equal sign, and you're trying to get everything onto this side and isolate x. Alright, so let's start. We always start with addition or subtraction, and then we'll move on to division and multiplication. So, we'll subtract the 2 from this side, as well as this side, and we'll have 2x is greater than or equal to negative 2, and then from there, we'll divide the 2 and divide the 2. And then we will get x has to be greater than or equal to negative 1. And that would be our domain for f of g. And you can prove that. If this were negative 1, 2 times negative 1 would be negative 2. Negative 2 plus 2 would be 0. 0 square rooted makes it unsolvable. Therefore, proving that our domain has to be greater than or equal to negative 1. That x has to be greater than or equal to negative 1, excuse me. Alright, now let's move on to g of f. So, g of f is the same thing except opposite. So now, we'll write it like this. G of f is really the same as this. F. It's the same way we've been writing f of x, except backwards. Now, instead of starting with our g factor or function, we'll start with our f function. So, we know that our f function is square root of x plus 3. So we'll do g of square root x plus 3. Then, this time, instead of factoring our g function into this x, we'll factor this into our g function. So our g function is 2x minus 1. So our g function is 2x minus 1. So now this x plus 3, square root x plus 3, will replace where the x was. So if we had 2x minus 1, it is now 2 square root x plus 3 minus 1. And there's no like terms to combine here because this is inside the square root and this is outside, so these aren't able to combine. So now that we know that x cannot equal negative 2.75, let's prove that that's correct. So, plugging this in, we get negative 2.75 plus 3 is positive 0.25. The square root of 0.25 is 0.5. 0.5 times 2 is 1. 1 minus 1 equals 0. Therefore proving that x is not able to equal negative 2.75. And that is how you solve for domains in composite functions.